I'd like to say a couple of things about R20. You've seen all these amazing presentations. R20 is a breakthrough in new features and a new functionality. I'm going to show a few of these things which have a slight overlap to what you've seen done by all the other artists. And I'm going to try and give a more practical spin to it. So we're going to start with blank scenes and just build some things up. So let me show you a couple of very, very basic animations I put together the last couple of days, which means the last few hours. So one is this kind of bullet flying through Jello animation. And everything I'm going to do includes fields and volumes to a certain extent. And one of the great aspects of all our new technologies is that they are connected, they are compatible with all the legacy stuff, with particles, thinking particles, standard particles, splines, either procedural or editable and so forth. And I'm a fan of procedural workflows, and I'll show you how to do things like this and changing parameters just by switching a few attributes. The other thing I'm going to show is this little thing which is a unified surface, and this is kind of boiling up. And again, it's a relatively straightforward setup. And I need to go slower because I can pull these off in about 15 minutes. So I'm going to talk in between to extend my presentation. And at the same time, I'm going to show you a few more things just to make sure you comprehend certain things about how the new functions work. Mind you, anything you feel I've missed or anything you don't understand, for all these new tools, we're going to have extensive features on Cineversity. So if you haven't still signed up for free on Cineversity, go sign up. Watch for Cineversity on YouTube as well, and all the playlists. And one last little thing in my first 5 minutes I need to say is that this technology is so new in the Cinema 4D ecosystem that although we have been exposed to it as beta testers for nearly a year, we haven't seen the beginnings of how the magnificent genius artists are going to use this stuff. So I personally am confined to my own little perception fatigue, and I'm going to try to explain a few things. And over the next few months, as artists start to use these features, we're going to have more tutorials, more complex setups, and resources to learn everything you need to learn. So, who hasn't watched any of the other presentations that shows volumes and fields? Okay, so you. Okay. So then let's just begin and do that. I'm going to start with something I didn't show you, something that's fun. I'm going to create a sphere. Thank you very much. That's all I have to say about this matter. I always make this joke, so it's getting a bit boring. So this is a procedural sphere, and what I'm going to do is grow some hair on it. So I'm going to go to my hair object, add hair. And anyone that's used the hair system knows that it creates these guides, but I want to actually make it create splines. And there's a function in the hair object. If you go to the generate and you set the none to splines, this will generate splines. We've got a few too many. I'm going to take it down to 500. And I'm going to turn off the dynamics because now they all kind of fall down. And I don't have hair, so this is a bit triggering for me. So I'm going to set my gravity to 0. And one thing I'm going to do, which doesn't do anything, but I like to do it anyhow, is in the forces, I'm going to set hair to hair and just make this 10. Good. So I'll press play. If I press play now, I need to do this. If I press play now, nothing happens, which is the best case scenario for me. Nothing happens, we're fine. But I'm going to use the hair material. I don't care about the color or the specular or the thickness. I do care about the length, the frizz and the kink. And if any of you haven't actually played with Cinema 4D's hair system, you're missing out. It's a fantastic and very powerful hair system that's been there for a while. And you can control so many parameters. Look at all those splines now. I say wiggly. But no new features yet. Well, let's do some new features stuff. So, volume builder, which is a generator that creates a volume either of an SDF type or a fog type. And if you had taken the time to watch my tutorials in university, you would have known what I'm talking about, okay? So I'm going to make these children, and then I'm going to create what's called a mesher. And this mesher takes the mess you see here and actually makes something interesting out of it. So this is a very interesting setup. You can charge your client about $272 for that. So we're going to increase your income now by adding a bit more complexity to this, okay? I've always wondered, do clients watch these things? I maybe need to watch my words. Anyway, so here's the layout. I'm going to go to the volume builder, which is responsible for building the basis of what is meshed by the mesher. And I'm going to select the element I want in my list to define things like the radius. So you see the radius of every one of those splines now. That's why we get this blob. It's 15 centimeters. So if I go and start pulling it down, now you're going to see a bit more defined structures happening. And then we get this. They disappear. And that is because of two aspects. First of all, our volume is not that high resolution. So I'm going to set this to 2. The smaller the voxel size, the higher the resolution. Just like with with pixels and images. The smaller the pixel, the more pixels we can put in the same space. So I'm going to make this even smaller, and you can see as we're going down to, let's say, something like 5, these now become little blobs. And the reason they're becoming blobs is that the way splines are transferred into the volume context is by creating little spheres, because volumes need surfaces, and a spline is not a surface, therefore there's an intermediate transformation. So by increasing the density, we're actually going to put more spheres, and now we have spaghettios, or spaghetti, or something like that. So this is quite cool. The good thing about this is that if I add any animation that affects the hair, it's actually going to affect what we see here. And let me make this a bit better looking. And someone made these icons huge, so I think... See, one of the things I'm not sure... Oh, there they go. I never use this, so I wouldn't know where it is. Good. So if I press play, nothing happens now. But if I go and add an element that affects the hair, something will happen. So one of those elements are our standard particle modifiers. So if I add a turbulence and go to my object and increase my scale a bit and press play, now we have a jiggly thing. It has to calculate the volume, but you can see things are slightly moving around now. So just like that, with 5 objects in our object manager, in our scene, we've created something which is very convincing if we're doing any kind of organic and medical animation, a cell or something like that. And all the parameters that apply to the hair system, like making them longer, shorter, the frizz and kink and all that, apply to this case. We can even reset the dynamics to work, so we can do that. Now, having said that, there's something about this scene that bugs me, and that is that all these little legs have the same thickness. I want to make them a bit thinner at the edges. So now I'm going to show you, of course I did it on purpose, like, ooh, I knew, because I need to show you how interconnected the system is. So we have this magnificent object in Cinema 4D called the MoSpline. And the MoSpline is an object that generates procedural splines using L systems and all sorts of other fancy stuff I had no idea about. I don't know how they work. But at the same time, it can resample splines. And the second aspect of it is that it works with MoGraph. So let's see what it does. I'm going to pull out my hair from my hierarchy. Fantastic. I'm going to put my MoSpline where this was, and I'm going to set my density back to whatever I had before, something like 3. And I'm going to tell the MoSpline to be in spline mode, which means it needs a driver spline to give us a new spline that will have added benefits. I'm going to drag my hair, which is a spline essentially, in here. And now what you will see is that we don't have the diameter anymore, because the diameter is controlled by the thickness of the MoSpline. So if I set this to 5, I'm going to have the same result I had before. Get rid of all those little extra lines. This is the same result as before, but, and here's the magic, I can add effectors. So I'm going to use a step effector. and I'm going to change my scaling to -1. So now each and every one of those splines is actually driven by the step effector and is becoming thinner. And all the other stuff like dynamics and so forth still work. And this is a primer of what you can do. Now imagine you can use particle forces, you can use hair, you can use the Mo spline to resample this, you can use an effector to change the size, which means we can add randomness in between and so forth. And yet, now we have 7 objects in our scene, and still the ability to create something which is very convincing, add a few textures and all that. And I like to do that lately. I've been told I need to make my images look a bit better. So I don't understand it, but I'll do it nonetheless. So let's go here. And the way I light scenes, because I'm never in a hurry, I don't do work for clients. I can always use PBR workflows. Fantastic. So I'm going to load an image here, some on the desktop. There is something called Siggraph 2018. It's 2018, isn't it? Yeah. Noseman, the new folder here. In my text, I have a really nice panorama from Dosh Design. And it's Frankfurt, pretty much where Maxon is based. Yes. And I'm going to add a sky object. And as you saw, this has nothing to do with R20, but I always put, when I'm using a sky for reflections, I put everything in the color. A lot of people put it in the luminance. Put it in the color. Everything else is wrong. Don't listen to anyone else. Email me and I'll explain why. So that is that. I'm going to add a nice little car paint material from the new assets from our nodes. And generally, this goes quite deep. I'm not going to show you. I don't want to scare anyone away. Fact of the matter is that we have all these new great assets. We're going to make a cell that has a car shader on it. I don't know what that is. Some genetic mutation. Go to compositing. Tell my sky, I don't want it visible in camera, so it just shows in my reflections. And then all I have to do is just switch this to physical if I want to. I don't need to. And just render. And there you go. We have something that looks much better than a gray on gray. And that is technique number 1. Did anyone not like it? Okay, good. So is this giving you ideas for stuff you're doing like woo? What you need to understand is that all these years, MoGraph being this amazing tool, it was confining us to more rigid structures. Amazing rigid structures, but rigid structures nonetheless. Imagine now bringing the power of MoGraph into the flowy, organic world. So we can do fake fluid simulations just by using standard particles and all that stuff. So it's quite funny. So let's move to the second technique now, which is, again, you may have seen some of these things done by other artists. I'm going to do a very simple filling up effect. So I'm just going to create some text. I'm going to create a seed, and that's going to fill up. Because I've seen a lot of motion graphics done where they want to fill up a surface with water or reveal something and so forth. And while I'm doing that, I'm going to show you some of my preferred workflows. So let's write something like, I don't know, grow. And let's use one of my favorite typefaces, which is Impact. There you go. And yep, this is good enough. And what I'm going to do is create an extrusion to this. And this is done. So what I do when I'm using volumes, I like to be able to reference the object a few times in different volumes to do different types of effects. As Chris and the GSG guys showed, sometimes by combining volumes together, you can create extremely complex structures, which, although they're organic, they look quite engineered as well. So what I like to do is I create an instance out of the geometry I'm going to use. Now, not a render instance or multi-instance, just a typical instance, which is nothing more than an absolute copy of that object. But that object still has geometry and everything else. And I make a null, so I'm going to just group this, and I'm going to make that invisible. Okay? So here's my object, and I'm going to create a volume builder. I'm going to set it to fog, and I'm going to set this to 2, so it has more resolution. I'm going to put this in here, and now we have all these little points, which are voxels. Everything that's white has a value of 1. Everything that's black has a value of 0. And if you watch my tutorials, you'll find out exactly why this is the case. So what I'm going to do is add a mesher to this, because as you know, if we mesh this, if we render that, nothing will happen. And there we go. We have this little grow. So what I'm going to do is use fields in the volume context. And my preferred way to have better organization of my scene is to create a group field. This group field is basically an empty layer. It has no data whatsoever. And I'm going to stick this guy in here, and you'll see a square hole happening there. And the reason is that the way the volume builder is built, because a volume needs a surface, the first thing happens when we drag a field inside our volume list is to tell us, all right, make a box, because a box of these dimensions will allow the volume builder to have something to work with. But because I already have an object underneath it, I don't need to do that. So in this case, I'm going to switch this to object, which means now my field is affecting the existing object structure and is erasing everything because it's putting a 0 over everything else. Okay? Or 1, whatever. Anyway, it's doing something we don't want. So now in the group field, I can start adding things that will reveal my volume. And the simplest thing you can do, number one, let's create a sphere, a spherical field. I can create some sort of, spotlight effect with this. Move it around, and wherever that sphere falls, I get my object. So the simplest way you can use it without going into any complex things is add a lot of these and just animate them and reveal your logo piece by piece. And you can use splines, you can use anything. You can make puzzle pieces. There is no end to what you can use. I'm going to use a sphere now because it's simple and I'm extremely lazy. So the path of least resistance. I think humans' evolutionary advantage was laziness. I think that's my conclusion now. That's why we're at the top of the food pyramid. Good. So now this is a solid structure. If I press play, nothing will happen because I'm not telling it to do anything different, no keyframes or anything like that. But what happens is that with the new system, we have all these amazing control layers, the white layers. And one of them is called the freeze layer. The freeze layer is a data layer. So all these are data layers, the white ones. Is a layer that records the current state of what's going on. And after it's recorded it does something based on the menu here. And when that is done, it re-records that state. So if I say grow and press play, it's going to start growing. Okay, that's it. And let me show you a few things about this. You see that it stopped at G. We have the other 4 letters. The reason is because this is a volume, because this is a volume, you can see that everything is basically little dots, little voxels. And these voxels have a defined distance. If the grow parameter is smaller than the gap between 2 voxels, there's nothing to grow into. Okay? So if I were to do something like, if you make this out of glass and you want to fill it with water, you will need to create channels so the water can flow from one to the other. As simple as that. So if you wanted this to continue and fill the whole thing up, all you have to do is go and add to your volume little cylinders that do precisely that. So let's do that and create a cylinder, make it small. Good. Let's put it on over there. Let's change its height. And now I'm going to turn this off so I know what I'm doing, where I'm placing it. Let's go to my side view. Good. Good. So I want it to flow that way. And I can make this quite small. There you go. And I'm going to make a copy. Actually, I'm going to make an instance of that so I can have them all the same. Then I'm going to say I want this to flow from here. Then make a copy. I want it to flow from here. And grab all these, this and this and this and this, 1, 2, 3, drag it in my volume builder. And these will become part of the whole thing I'm doing here. Did I do that correctly? Yep. I just need to take all these and put them underneath. There you go. So now, if I rewind and press play, I think that it's going to transfer the growth through that little pipe and move to the next one and move to the next one and move to the next one. So again, with a very small number of objects, we're creating an automated, no keyframes, by the way, an automated setup where we get this automatic growth, which is nothing more than an infection of data from voxel to voxel. That's all it does. So the good thing with this is that our original seed was a sphere. If I wanted to create a situation where this is filling bottom up, all I have to do, I can even remove all my cylinders and everything else. I don't need these anymore. What I could do is go here, let's select the field here, and say, you know something, I want a linear field. I'm going to set it to +y, make it smaller, rewind, always remember to rewind, and maybe I need to go to this guy and clear, freeze it, and see what happens. Oh, I'm going to set this to add. Yep, I just need to reverse my field to minus. And there you go. So now my seed is this layer here. I can control how thick I want it, and I need to make it, there you go. So this is my original seed, and everything grows in the same manner from that seed. So we have one setup, and just by changing the shape and the position of something, I can make different things. I can have two seeds, and they can grow inwards, outwards. I can grow two volumes from two different places with two different liquids, so to speak. So again, this is just a very, very small indication of how you can create procedural, more organic things. Now, many are worried, like, but this is too jaggy. Yeah, why don't you put it under a smooth deformer and leave me alone? That's there you go. So, or why don't you put a smooth layer on top of it? Yep, right on top. There you go. So I can smooth it out. I can make balloon text. And because everything is based on the original extruded text, regardless of how many copies of this volume we have in our scene, all I have to do is go and change the extrusion on this one, or I can go and change the text on this text, the nose, and there you go. And everything works. It's still 100% procedural, no keyframes or anything like that. Good. So filling text with water, done. Now, the next one I'm going to show is the bullet going through the gel. Okay, so anyone that wasn't here from the beginning, shame on you, but here it is. So we're going to do this effect, and again, it's only going to have two keyframes, where the keyframes of the bullet start and end position. Everything else is going to be calculated. So I'm going to take the same thing here, create a new file, paste it here, make an instance of this. Again, I don't need to do that. So let's call this bullet. There you go. So let's create our volume. So I'm going to create a volume builder and a volume mesher and do this. I'm just going to leave it at SDF now. Increase the resolution to what I'm used to. Okay, so we have our nice text here. And let's create a bullet. So this is a modeling 101. Use an oil tank. Make it smaller. Do that. Do that. Good. Make it editable. And go and select this loop. Go to select, fill selection. Do that and do that. And one of the best features of Cinema 4D R20 is that when you delete points, it deletes polygons as well. Sorry, when you delete polygons, it deletes points as well. You can always keep the previous functionality by pressing Shift. So what I'm going to do now is just make sure, oh, that's good enough. I'm fine with that. So I'm going to rotate this. I'm going to make it ever so slightly smaller. Move it to the middle of my text. Move it up. And let's do a quick animation. Let's go here. Let's go to the oil tank coordinates. Let's freeze transformations. If you don't use freeze transformations, please start using them. Go to frame 90. Let's just fire this through here. Good. Keyframe, right-click here, animation, show F-curve. Just want to change this. I want it to have a constant velocity, and then I just want it to go and stop a bit abruptly. So yeah, it's a slow-motion bullet, and it goes like that, and it stops. Good. So these are the keyframes I'm going to add, nothing else. So I'm going to use all this information to create exactly what I want. So number one, as I told you before, we can use splines, particles, and all sorts of other objects in the volume context. I want, when the bullet goes in, I don't want the bullet itself to subtract, punch a hole, because as it moves forward, that hole will close behind it. I want that hole to stay open. So that is basically the bullet's trajectory. So how do we extract a trajectory from a motion? Well, it's quite simple. We use our fantastic tracer. With the bullet loaded here, I'm going to turn off the vertices, because if I don't, I'm going to have all these nice little lines here. And now what the tracer is doing, it's tracing a line, it's generating a spline from the bullet. So I'm going to take this tracer, put it in here, and simply set this to subtract. Select it. Radius 15, I'm going to check it out. Density, let's put 4, so we have nice, and we have a hole. So as the bullet is going through, it's actually punching a hole. It's not the bullet that's punching the hole. It's actually the spline that's been subtracted by the volume, and then the volume being meshed. So we're fooling it into believing that the bullet is doing everything. So let's go back. Do this. I moved my bullet a bit. Now it's in the middle. Excellent. So phase 1 is ready. But as you remember, I get this bulging effect going on. And in order to achieve that, I'm going to use fields now in a totally different context. What I'm going to do is my volume mesher, which is a highly tessellated, subdivided surface, because that's the nature of the mesher. Because it's got high subdivision, I can use a deformer with great ease. So I'm going to use the simplest of all deformers, the plane effector in deformer mode. So let me make this a child of a null, make this a sibling, tell the plane effector to go point mode, and look at this magnificent thing. Ah! So then change the parameter to z, which is basically the normal direction. Let's say 10. So you can see it's bulging out. So what I need to do now is constrain this effect of the effector on that spline. Well, that's very simple. Because we can drop anything, literally anything, inside the fall-off, I'm going to use the same tracer here. And I'm going to set this tracer to the mode that's called, over here, radius. And I'm going to extend the radius, and there's my bulge. Just a plain deformer. You can play around with fall-offs and all that to give it a better shape and whatnot. I'm not going to bother with those things because I have more serious things to show you. And then I think, if it doesn't fail, I'm going to add a random, set it to minimum, which is one of the modes here. These little layers are like Photoshop layers. If you want to experiment with the modes, you can recreate them in Photoshop and start using multiply, add, screen, and all that. And, of course, watch the tutorials that are upcoming that will explain everything for you. So random field view settings, turn it off. That will be nice to be default function. So there you go. The noise is only applied to the bulge. And all we need to do is put some nice materials to this. And I'm not going to do it right now because I need to show you the bubbles, which is a bit more complex. So let's move on to the little Torus Boils. There you go. So let's do that again. Okay. Sound always helps sell the story, all right? So we are going to take advantage of other features now. Again, we're going to stick the standard workflows with the new workflows and see how things go. And if anything goes wrong, I would say, well, I'll make a tutorial. So it makes them feel so comfortable now up here. I have the power of tutorials. So we're going to begin with a torus. Normally, everything begins with a cube, but, you know, I'm breaking new grounds here. So make a torus. And I'm going to use this torus as the object to create the main object for my volume, but as the source to generate the little bubbles. So as usual, I'm going to make it a child of a null, select it, make an instance of it, and name it volume torus. Fantastic. Make a copy of this and name it emitter torus. At least a keyboard that works, the best keyboard ever made. So what I'm going to do now is hide the volume torus. And I'm going to use this in the following way. A simple cloner, a simple sphere. The good thing with bubbles is that because they're spherical, it's always simple to make them. And I want to clone the spheres on an object, and the object is going to be the emitter. Okay? So now we have a bunch of spheres on the surface, as it says here, 20 spheres on the surface of our torus. Now, there are a couple of problems here. I want to emit them from inside. I want them to be smaller. And then I want them to go outwards, become bigger, and then explode. OK? So let's start one by one. Let's make my spheres smaller. So I'm going to make them, I don't know, 10. Nope, I think we need to go a bit bigger. Actually, I'm going to make them small to begin with. My emitter needs to be smaller, but I want to keep the same object, mind you. I can't scale it down, because scaling it down will scale it like this. I want to bring it in the surface. So what I'm going to do is pretty much the same I did before with the bulging from the bullet. I'm going to set a plane effector, set it to point mode, tell the parameter to be minus 10 in the z, or minus 20 in the z, or minus 30 in the z, or minus 48 in the z. So now I'm emitting these little bubbles from pretty much the center line of my torus object. OK, fine. And I may even make them smaller. What is not happening is that these little buggers are not moving. And how do I fix that? Well, thanks to our fields technology now, I'm going to call this clone bubblers, clone bubbles. I'm going to add another plane effector. And I'm going to call this plane move scale. Now, a plane effector, like every other effector, let's put this to 100, defines a certain transformation, position, scale, and so forth, position in this case. How do we make it so that this position, the final position, is achieved through time? And the way to do that now with our new field system is that we can use, in the fall-off tab, what's called a time field. The time field now is set to 30 frames. And what it's telling us, which is very similar to our time effector, is that the value from 0 to the maximum value that the effector is providing is going to happen within a span of 30 frames. If I press this button, they're going to move for 30 frames. So what you're seeing here, funny enough, is we can approach the let's say, capabilities of a deterministic particle system. If you don't know what I'm talking about, don't worry. The second thing I want to do is scale them up. As they're going out, I need them to become bigger. So I'm going to change the scaling. So now they're going to grow. How much they're going to grow, I'll bring this up. I'm going to tweak this so that, and when I say deterministic, I mean you can scrub. It doesn't need to calculate anything. Everything happens in a fashion where it doesn't need to know what happened before. So what I'm going to do is go here and just using my arrow keys, I want to place them in their final position. Eyeballing is the most accurate instrument on the planet, and my favorite way. And I want to make them this big. Good, that's their final size. So now I have their minimum size and their maximum size, and while they're growing, they're going out as well. And with a couple of numbers, you can tweak that. Excellent. So we got our bubbles bubbling outwards. Now, the next thing I want to do is randomize it, because they're all going... Bubbles never go in unison. We know that. That's a life experience for you. So what I'm going to do is go in here in my list, and I want to randomize this somewhat. So I'm going to add a random and multiply it, or subtract it, or something like that. But anyhow, now I'm getting this randomization. So you can see that now they're coming up in different time frames, okay? Which makes it extremely interesting. Let me extend this a few frames. I just experiment with these. I'm never sure exactly what I want to do. Let's see. Yeah, that works as well. And it's a bit more accurate. So we've got our randomization. We've got our generation. The next thing we need to do is the popping. We need to find a way so that just a few frames after they reach their final position, we want them to pop. So because we're going to use the same kind of timing, what I'm going to do here is make a copy of the plane move scale and call it plane pop, right? Sorry, plane pop. And what we're going to do is set that to have a parameter not of position and scale, but a parameter of visibility, and apply it to my scene bubbles. So nothing happens currently because the values are inverted. Let's put it that way. In order to fix this, I'm going to invert the already existing values. And the next thing I'm going to do, I think I need to do something with this. I'll remember. If I don't remember, I'll just go one by one until it works. So let's leave it normal. We'll see what happens. And what else do I need to do? And I need to use something like a range mapper to push up these values here to change the way. There you go. It works. I told you it's going to work. Why worry? That was a close one. So what I'm doing now is using the same data I was using to grow these, but I've assigned it to a different parameter and slightly amended the way the whole thing works. The first part of the animation is ready and is close to perfect. The next thing I want to do is create hollow little bubbles, because this now is going to become a big, massive object. So I'm going to do the following thing. I'm going to put my clone bubbles in here, and in my usual fashion, I want to create an instance. I'm not going to use an instance of that yet, but if I wanted to, I could actually do that. Great. So we have our instances here. We need a volume builder and a volume mesher. I'm going to put the builder in the mesher, and I'm going to put my bubbles in here and my volume torus in here. So now we have a unified structure that represents the meshing of that whole thing happening. I'm going to increase the resolution a bit, and you're going to see faceting happening. No problem. Go to our original object and increase, I don't know, 120 and 36 or something like that. I mean, just push up the values. I'm going to keep it a bit low just to make it a bit faster. So we have this. So what I need to do now in this situation is create a second set of smaller spheres, which I will subtract from the volume to create the little voids inside. So clone bubbles, I'm going to make a copy of this. I'm going to call it clone bubbles inside. Okay? And I'm going to take this, and I'm going to say I'm going to make an instance and drag this little guy in here. And I'm going to take it and subtract it. But now we're going to have a problem because we got two surface intersecting together, so we only see the holes. So I go to my second bubble, and I just make my sphere smaller. You just stop this for a second, go here. Let's make it 3. So now you will see that everything looks the same, but I promise you there are holes in the bubbles. So if you want to see them, just pause the frame there, go to one of my side views, and look at the interiors of the bubbles, and I can eyeball it and make them as big as I want. And this is the thickness of my bubble. So the more viscous the fluid is, the thicker the bubble. Even if that's wrong, it sounds so scientific, doesn't it? Yeah. So we have the basic stuff done. And of course, I could, say, yeah, thank you very much. But no, it's not ready yet. What I want to happen is that when the bubbles burst, I want them to leave a hole behind for just a few frames. Okay? Because currently, both the outer and the inner are bursting at the same time. So I'm going to do that in a non-standard way. So my inside bubbles are disappearing because they have the pop. I'm going to delete the pop. So now we have the holes. But I want these holes to get smaller, which is the equivalent of if the spheres were the inner spheres were moving further out. They didn't stop. Well, and in order to do that, let me do that and explain why that happens. I'm going to make a copy of my plane move scale, which is that parameter that moves them and scales them, and call this scale plane move holes. And in my bubbles inside, I'm going to replace them so they're still identical. put one here, and we're going to get exactly the same result as we had before. Now, with fields, there's three little checkboxes. And it's this little thing here. If you go on this side, you'll see that little blue thing, which is what's called the clamp. So by default, all the values we feed in the field system are constrained. The minimum is 0 and the maximum is 1. And that clamping allows for very, let's say, easy to understand math, because the plane effector has a value. At 0, it's 0, but at 1, which is the maximum, it has whatever the value is. If we unclamp this, then what's going to happen is that my spheres are going to continue moving out, thus giving us the impression. So although this effector is telling them to move from 0 to 50, we've unclamped that. So after 50, it just keeps on moving. So anyone that has used the F-curves knows that we have the continue, the ping pong, and all that. So just like that, just like making a copy of this setup, we have a fully procedural setup with bubbles that grow, go out, pop, create a hole, and then that hole is closed slowly. Of course, we can add more tweaks. For example, make them speed up as they go there, get smaller, do all sorts of things. But, you know, do that for work you get paid for, okay? And we're going to do an extensive tutorial on this. And to close things up, let's shade this and make it look beautiful. So in the color, let's just go and load my favorite Frankfurt, my favorite city. You can make jokes about Germans, all right? Yeah, cool. Yeah, thanks. I have to be very careful these days. So I'm going to add, again, my material there. I'm going to go to my compositing tag and remove my camera visibility. And let's create the simplest of all simple materials ever created. A transparency channel with a glass or water preset. Drag it on this guy here. And it's not going to look very nice at this point. Let's render it. And I'm going to do a couple of tweaks to this, right? So it's water. And what I'm going to do is go expand this. Absorption distance makes your glass look fantastic. Make it a bit gray. Take this down to 20. Render. And now we got this. If it's a bit faceted, don't worry. Let's just smooth it out. Put it under that. Put a smoothing deformer. And let's just put this a bit down. Let's see what that does. Nice and smooth. And there you go. Bubbles, holes, everything is deterministic, no calculation times. Let's add some lines there so we can see it. Maybe some transparency. No, I don't like the lines, but some transparency. And you can see everything. And it's all procedural. Now, setups like this can become even more procedural. In what sense? I've made 3 plane effectors that have the same lists. What I could have done is taking all the common elements, group them under a group field, and use wherever we use exactly the same parameters, use that group field. And we would be able to save ourselves from selecting this random and changing the values. And because I'm lazy, a click less is a click less. Right? So value is great. So because I have a few more minutes, I'd like to show some not project-based stuff, but just things to feed your imagination. So my very good friend, Sebastian Heffele, was that correct pronunciation? Basti. Hi, Basti. I love you. He actually showed me how easy it is to make a little probe to go and measure volume. So this is part of the geeky part of the presentation. But yeah, everyone likes a bit of... You wouldn't be here if you were not geeks, okay? Don't forget about that. So I'm going to create a volume builder. Now, for anyone that's watched my tutorials, there are a couple of things about the SDFs which are not obvious. So in this current state, voxel size, each little square is 10 centimeters, and the exterior range is, let's say, 10. Nothing changes other than the bounding box, and the interior ranges are 2. But what if I'm trying to take measurements? How do I know what is the value of each voxel in the ether over here. So 10 in this buffer. So the easy way to do it is you'll create a, we need a null, just because we can just move it around. And just going to move it out here and make it into a little circle, which I can see nicely, XY. There you go. So I have a little circle here. On this, I'm going to call it probe. And I'm going to create some text, because that text is going to give me feedback. I'm just going to send whatever the value is so I can see it. So what I'm going to do here is create a little espresso. Ooh. I'm going to drag my little null in here, and I'm going to create what's called a fall-off. And this shows off a bit of the power of the new field system, because the fall-off now incorporates the field system. So if you use Espresso in any capacity, you can drive any parameter in Cinema 4D using fields from now on. No excuses. Light intensities. Josh Johnson back there was experimenting. You could put a bunch of lights and throw something in, and the colors will change and all that. So I'm going to take my little probe null and get my global position, okay? Feed it in the sample position. In here now, what am I trying to sample? I'm trying to sample the volume builder. And because the volume builder has values which can exceed 0 to 1, all I need to do is unclamp this and unclamp the remapping. Again, all this will be clear as we go forward if you watch this university tutorials. Grab the text here, go to the text object, take the text, grab it here, connect it out, and now what we're going to see is the value of the voxel in this position. So this is a sort of a probe that allows us to move this around. And while you're learning what volumes are, this is going to give you the ability to understand what's happening behind the things I can't really grasp, I can't really see. And just to wrap this little thing up, if I put this under a volume measure, what you will see is that when the volume measure range goes to 100%, it goes to the outermost voxel available. And when it goes to 50, it's on the surface of the original cube. And when it goes to to 0, so it goes to the lowest extremity defined by this. So 2 voxels inside. So this little cube has 2 voxels inside and 10 voxels outside. Okay, so basically, this is all I wanted to show. But before you applaud me and you know, selfies and all that, I'd like to, besides to extend my thanks for Maxon once more for a great hospitality, I want to thank the Maxon developers and everyone that participated in this particular release, because we've been saying game changer all these years. I didn't mean it, but this time it is an actual game changer. The new stuff you're going to be able to do, the new world that opens up for artists. So my congratulations go to all the development team and design team and management team of Maxon, a lot of whom are here. So feel free to approach them and harass them, yeah, because they already have a bloated ego. So, yeah. And, yeah, I want to thank them for this amazing release. And we're going to see spectacular stuff coming out. And some people out there, I'm not going to tell their names, one of the developers I talk to very frequently, and the development support and everyone. Thanks very much. My name is Athanasios Pozantsis, a.k.a. Noseman. If you Google Noseman, I come up first. Noseman knows. And thank you very much for coming. Thank you. Thank you.